Hello guys, in this video I'm going to show you how to solve binary tree level order traversal. So given a binary tree, populate an array to represent its level by level traversal. You should populate the values of all nodes of each level from left to right in separate subarrays. So for example, we have this binary tree, right? There are a total of 3 levels. So the expected array that we want is, because it has 3 levels, right? So we have 3 subarrays. The first subarray will store the first level of the binary tree from left to right. There's only one element, so it's 1. The second subarray will store element of second level of the binary tree, so it's 2 and 3. Same for here, it's 4, 5, 6, 7. So this is kind of similar with what I've solved in some previous videos. It's pretty similar to level width problem, right? Same. We also need to traverse the tree by level. The only difference here is that we need to store all the nodes value. For level width problem, just a reminder, I need to store the number of nodes in each of each level. Okay. So 1, 2, 4. So I'll leave the link to this program in the description. So let's start. So whenever you see a problem that mentioning level traversal, instantly think of a queue. When I use a queue to store elements. For level by level traversal, it's breadth first search. So we'll use a queue. So here is our queue. It come out this way, it come in this way, and come out this way. So in order to solve, let's just try to iterate from the root node, right? So probably we want to at a certain point in our loop, we want to have all the nodes in one level in the queue, right? So we know exactly that at each level how many nodes. So we process, for example, level 2, there are 2 nodes, right? So we only process 2 nodes. Take it out from the queue, and while I take it out, we also push in children of current level, right? Children of current level. For example, we are processing 2 elements of level 2, while popping out 2 and 3, we also push in 4, 5, 6, 7. So probably we want to remember the number of each level, right? So that's the basic idea. Let's try to run through it manually. First, we push 1 to root node to the queue, right? So we also have result array to store. So probably the queue is now storing all numbers, all nodes, right? All nodes of level 1, right? There's only one node in level 1, so the queue is now storing all nodes of level 1. So we remember that there's one, remember there's one node, and we want to process that one node and pop it out from the queue. So the one that is out is, we take it out. The one out is 1. Right? We let's process it first. The one there's two children of 1, so we push in 2 and 3 to the queue. 2 first, then 3, and as we pop out the all nodes of the first level, we want to push to the result array. We create a new subarray empty, and we push one in. So now the queue has 2 nodes inside, which is all node of the second level, right? So it means our second subarray will have 2 empty slots, right? And as we popping out each nodes in the queue, we want to push in the children, its children also to the queue. So okay, before processing, we remember that there are 2 nodes in the second level, right? Okay, we process exactly 2, right? So the one now is 2. We push 2 here, and 2, there's 2 children of 2 is 4 and 5. 4 plus, then 5. Now we go to the second element, second nodes of level 2. We pop it out. The one now is 3, right? So what is the children of 3? It's 6 and 7. 6 come first, then 7. Okay, the one now is 3. We push it to the subarray, the second subarray, which is corresponding to second level of binary tree. So we've done with 2 elements of 2 nodes of second level. Now the queue contains all 4 elements, all 4 nodes of third level, of level 3. So it means there are 4 slots in the separate tree corresponding to level 3, right? So as we popping out, the first one 4, right? The one now is 4. 4 has no children, so we don't need to push any of the queue, but we need to update our result to separate current level, which is so 5 out, right? 5 is out. 5 has no children. Now 6 out, same here. 6 has no children. 6 to 7 now. 7 had no children. Now the queue is empty. We're done with our traversal, and now resolve array is exactly what we expect, right? And so the idea here is we use a queue. So at the beginning of each iteration, the queue always contains all the elements, all the nodes of one particular level, right? We want to process those amount, popping them out, then popping out as we pop elements. We want to add more children to the queue. So after we finish popping out, the queues contain all nodes of the next level, and so on. We keep processing, we keep doing like that until the queue is empty. So let's code it out. We need a queue, right? Queue in JavaScript is just an array. So initially we have the root node, right, inside the queue, which is the first level. Let's say we have result array also. Return result. We want to process as long as the queue is not empty, mean there's something in the queue. We want to process. So at the beginning of the of one iterations, the queue contains all nodes of current level, right? So let's make it clear by define a level size queue length array. We want to process exactly this amount of nodes, right? So how about using a loop, another loop? We run from I to level size. So for each node we want to, so for the queue we want to use, let's say, push and ship method. Ship is push e means NQ and ship is DQ. Push, it means pushing to the end of the array, and ship is popping out from the head of the array. Here's NQ. So we need to pop out that node, the level size element, right? Q dot ship. So we want to push in all children of node, right? So here's a node, left and right. So how can we do it? So let's say if node.left, which one will process first? Left first, right? Left first, because we want to populate from left to right. So it means we want to push the left to Q first. So the left is will pop out first. Q is first in first out. So if not the left, then we push to the Q. We end Q, right? Not the left. And if we have not right, we end Q not right. So after exists the Q, we have process. All nodes of current level, but one thing that we're missing here is that we need to push the node to separate, current node to separate. So at each level, at each iteration, we're processing one level, right? So probably we want to push into the result on empty array, right? So down here, we want to get the last subarray, which is result, which is the one at the last index, right? Result length -1. Here the last subarray. We push in what? We push in node dot val. So we push the subarray. We process all the children so that they are available in the queue in the next iteration as we process the next level, right? So I think that's pretty much it. Let's try to run the test. Just 7 and 1. Hopefully it will work. Don't think there's anything wrong with this. Okay. So that's it. Thank you for watching. See you in the next video.